Hi, Mr. Hammy here. In this video, we're going to be talking about some useful trigonometric identities that are very useful in our Year 11 Maths course. So I'm going to be explaining two extremely important ones, and the first one is known as the Pythagorean identity. Okay, it's extremely important and very, very useful. Okay, so we start off with this unit circle, circle with a radius 1, and I'll draw a right-angled triangle within it, and you'll remember that the x-axis gives cosine of that angle, the y-axis gives sine of the angle, and of course the hypotenuse here is just the radius, so it must be 1. There must be 1. Now, hopefully you remember with any right-angled triangle, you remember Pythagoras' theorem. Here's the hypotenuse. Let's say this is the adjacent side and this is the opposite side. Pythagoras' theorem says that the hypotenuse squared is the adjacent squared plus the opposite side squared. Or in other words, a squared equals b squared plus c squared. Some people like it like this, some like it like this, doesn't matter. That's the Pythagoras' theorem. Now with this, so x is actually cosine of theta, y-axis is actually sine of theta, so we can change the Pythagoras identity to, so it's the adjacent side squared, so that's cos squared, plus the opposite side squared, that's sine squared, equals the hypotenuse squared, 1 squared. Okay, so 1 squared is obviously 1, so we have cosine squared plus sine squared equals 1. And that is the Pythagorean identity. It is extremely extremely important, so remember that. Cos squared plus sine squared equals 1. Alright, let's do a tiny example. Example 1. If cos of the angle equals, cosine of the angle equals, let's say, a quarter, find sine of the angle. Okay, if cosine angle equals a quarter, find sine of the angle. Well, first let's put in the identity, cos squared of the angle plus sine squared of the angle is 1. So therefore a quarter squared plus sine angle squared equals 1. So therefore a quarter squared is 1 on 16 plus sine squared theta equals 1. So sine squared theta is 1 minus 1 on 16. So sine squared theta, 1 minus 1 on 16 is 15 on 16. So sine of theta has to equal plus or minus the square root of 15 on 16, or plus or minus root 15 on 4, if you like. Sine of theta. So there you go. There's that question done. So if you know cosine of the angle, you can find out sine of the angle, and vice versa. If you knew sine, you could find out cosine. Okay, so there's the Pythagorean identity. Next identity is just another form of tan. So we know that tan of theta is opposite over adjacent. We also know that that sine of theta is equal to the opposite over the hypotenuse, and we know that cosine of theta is the adjacent over the hypotenuse. So what I'm going to do is I'm going to try and do sine divided by cosine. So sine is opposite over hypotenuse divided by cosine, adjacent over hypotenuse. So this is the same as, so hopefully you remember our flip and multiply technique when you're dividing by a fraction. So we've got opposite over hypotenuse multiplied by hypotenuse over adjacent. So hopefully you remember that. The method for dividing by fractions. And so here our hypotenuses cancel out and we're left with opposite over adjacent, which is, opposite over adjacent is tan. Tan of the angle. So therefore, tan of theta equals sine of the angle over cosine of the angle. So if we know sine, we know cosine, we can find tan. So there's a very important identity. So let's put that identity next to our other identity, sine squared angle equals there you go. So here if we know sine and cos, we can find tan. If we know tan and cosine, we can find sine. If we know tan and sine, we can find cos. Here, if we know either sine or cosine, we can find the other one. So that means if we know sine, we can find cosine and the tangent. If we know cosine, we can find sine and the tangent. But if we know the tangent, we can't figure the other ones out just using that knowledge. We can't be quite sure. So let's do an example using both of these. Okay, so example 2. If sine of theta equals let's say sine of theta equals 2, find cosine theta. Oh, maybe let's not make it 2. Let's make it a half. Sine of theta equals a half. Find cosine of theta and tan of theta. Okay, so first we'll find cosine using the Pythagorean identity. So we know that, so sine is a half, so that'll be a half squared plus cosine squared of theta equals 1. So that's a quarter. So a quarter, and then we'll do the minus. 1 minus a quarter equals cosine squared of theta. So 3/4 equals cosine squared theta. So cosine squared theta must be the square root plus or minus the square root of 3 on 4. Oops, don't need the squared, we've done the square root. So there we go, we're halfway there. Now we need to find the tangent. So to find the tangent, we can say that sine of theta over cosine of theta is tan theta. So sine of theta is a half, cosine of theta is plus or minus 3/4, square root of 3/4. So there is basically our answer. Let's neaten this up a little bit. So we've got a half divided by plus or minus square root of 3/4. So just doing this bit here where we divide our fractions. So basically this 2 drops down to the bottom and this 4 comes on up to the top. So we've got 1 times our 4, so 4 is at the top, divided by our 2 by our root 3 down the bottom, and we've got this plus or minus happening as well. Plus or minus. So that is plus or minus 4 on 2 root 2. Now if you want to at this point, you can, so that answer is perfectly fine, that is correct. If you want to at this point, you can multiply by root 2 on root 2. Multiply this whole thing by root 2 on root 2. Root 2 on root 2 is 1, so you can multiply something by 1, doesn't change it. And let's see what happens. We get plus or minus, well, 4. 4 divided by 2 as well. You can cross those out and make that a 2. So at the top we've got 2 root 2. Down the bottom we've got root 2 times root 2 is 2. Now the 2 crosses out with the 2. So we get plus or minus the square root of 2, which is the most simple form. So that's 2 ticks worth of answer. So there we go. Tan of theta is plus or minus square root of 2. So there we have it. 2 very important identities.